Triangle trigonometry, the six trigonometric ratios. Our objectives. At the end of this presentation, you should be able to illustrate the six trigonometric ratios: sine, cosine, tangent, secant, cosecant, and cotangent. Let's start. What is trigonometry? The word trigonometry comes from the ancient Greek word trigon, meaning triangle, and metron, meaning measure. Therefore, trigonometry is the study of triangle measurement. Right triangle trigonometry is often used to find the length of one side or the measure of an acute angle of a right triangle. The sides of a triangle can also be named according to their relationship with a given angle. Remember that the hypotenuse is always the side opposite of the right angle. Thus, it is the longest side of the right triangle. The opposite side of the hypotenuse is called the opposite side, and the remaining side is called the adjacent side. Given triangle ABC. In relation to angle A, the side A is an opposite side, while side B is an adjacent side. In relation to angle B, the side B is an opposite side, while the side A is an adjacent side. Take note that in a right triangle trigonometry, these relationships do not apply to angle C, which is our right angle. Trigonometric ratio is a ratio of the lengths of the sides of a triangle. The three basic trigonometric ratio are sine, cosine, and tangent. Remember the acronym SOHCAHTOA. So is sine, opposite, and hypotenuse. In mathematical symbol, that is sine theta is equal to opposite side over the hypotenuse. Ka is cos, adjacent, and hypotenuse. In mathematical symbol, that is cos theta is equal to adjacent side over hypotenuse. TOA stands for tan, opposite, adjacent. In mathematical representation, that is tan theta is equal to the opposite side over the adjacent side. Theta is the symbol used to denote the unknown measure of an angle. Let's define more the six trigonometric ratios. So remember the sine, cosine, and tangent because these will be the three basic trigonometric ratios. For all right triangles, ABC with acute angle A. Therefore, our reference angle is angle A. If this is my reference angle, remember that the opposite side of angle A will be what we call your opposite leg, and the other leg is what we call your adjacent leg. Therefore, sine A is equal to the length of opposite leg over the length of the hypotenuse, or in representation that is sine A equals A over C. Cosine A is equal to the length of adjacent leg over the length of the hypotenuse. In representation that is cos A equal B over C. Tangent A is equal to the length of opposite leg over the length of the adjacent leg. In representation that is tan A is equal to A over B. Cosecant A is equal to the length of the hypotenuse over the length of opposite leg. Or CSC A is equal to C over A. Remember that the cosecant is just a reverse of sine. Secant A is equal to the length of the hypotenuse over the length of the adjacent leg. In symbol, that is secant A, or sec A is equal to C over D. Remember that secant is the opposite of cosine. Cotangent A is equal to the length of adjacent leg over the length of opposite leg. Or in symbol, that is cot A is equal to B over A. Remember that cotangent is the opposite of tangent. Example. Refer to the figure of triangle CAT and find the ratio. Sine T. Therefore, our reference angle is angle T. And since that is sine, we know that sine T is equal to opposite over hypotenuse. So substitute the given. The opposite side of angle T is 5, or side CA, over the hypotenuse is CT. So substitute the value, we have 5 over 13. Therefore, sine T is equal to 5 over 13. Let's have cosine C. So our reference angle is angle C. We know that cosine C is equal to the adjacent side over the hypotenuse. So if my reference angle is angle C, obviously 80 is the opposite, therefore CA will be your adjacent side. So that is CA over the hypotenuse is CT. Therefore, cosine C is equal to 5 over 13. Let's have tan T, or tangent T. So we know that tangent T is equal to opposite over adjacent. So if my reference angle is angle T, the opposite side will be CA and the adjacent side will be AT. Therefore, tangent T is equal to 5 over 12. Let's have the last one, secant C. We know that secant is opposite of cosine. Therefore, if cosine is adjacent over hypotenuse, secant C is equal to the hypotenuse over adjacent. So if angle C will be my reference angle, the hypotenuse is your CT over your adjacent, which is CA. Substituting it, our answer will be 13 over 5. Find the 6 trigonometric ratios for each acute angle in the given right triangle. As you notice, one leg of the given right triangle is missing. Therefore, we need first to find for the missing side of the given right triangle. Since this is a right triangle, we will be using the concept of the Pythagorean theorem. So let's say the missing side will be x. So I can say that this is x is equal to the square of the longest side, which is 5, minus the other leg, or the square of the other leg, which is 3. So we can say that this is x is equal to the square root of 25 minus 9. X is equal to the square root of 25 minus 9 is 16. Therefore, x is equal to 4. So the missing side or side BC is equal to 4. We can now find for the sixth trigonometric ratio. So we will be finding out sine A, cosine A, tangent A, cosecant A, secant A, and tangent A. We'll also find for sine B, cosine B, tangent B, cosecant B, secant B, and tangent B. Now, one technique that you can actually apply is to write the opposite, adjacent, and the hypotenuse side of each of the following angle. So if my reference angle is angle A, I can write this as my opposite side, adjacent side, and hypotenuse. So this is then on the other part, that is B. So let's go first on angle A. So if angle A is my reference angle, the opposite side of that will be side BC, which measures 4. Therefore, CA is my adjacent side, which is equal to 3. And obviously, the opposite side of the right angle will be my hypotenuse, which is side BA, which measures 5. If my reference angle is angle B, the opposite will become CA, which measures 3. Then BC will be my adjacent side, and again, hypotenuse will be my BA. Remember that you can interchange the adjacent and opposite side depending on your reference angle, but never the hypotenuse, because the hypotenuse will be your longest side. So we can now substitute by the given value. Always remember your SOHCAHTOA. Then you got CHO, SHA, KAW. So sine is SO, that is opposite over hypotenuse. So the opposite side will be 4, and the hypotenuse will be 5. So sine A is 4 over 5. Ka is cosine, that is adjacent over hypotenuse. So if angle A is my reference angle, the adjacent will be 3, and the opposite will be, the hypotenuse is 5. Tan is TOA, that is opposite over hypotenuse. So the opposite is 4 over the adjacent, which is 3. Now, to get the remaining 3 trigonometric ratio, you will just simply get the opposite of sine, cosine, and tangent. For cosecant A, that is the opposite of sine A. So if sine A is 4 over 5, this is 5 over 4. If cosine A is 3 over 5, secant A is 5 over 3. If tangent A is 4 over 3, so this cotangent A is equal to 3 over 4. So let's have for B. If my reference angle will be B, what will be my sixth trigonometric ratio? So for sine, that is opposite over hypotenuse. So the opposite will be 3. And again, 5 will be your hypotenuse. So this is 3 over 5. For my cosine, adjacent over hypotenuse. So my adjacent is BC, which is 4. Hypotenuse is 5. Tangent B is opposite over adjacent. Opposite side is 3. And adjacent is 4. So same procedure, you will just simply get the opposite of the three basic trigonometric ratio. For cosecant b, that will become the opposite of sine, which is 5 over 3. For secant b, that is 5 over 4. And for cotangent b, that is 4 over 3. Given theta, an angle in a right triangle, the sine theta is equal to 5 over 13. Find the remaining trigonometric ratio. So again, the other side of the given triangle is missing. So therefore, we'll find for the missing part. So let's label this as x. So this will become x is equal to square root of 13 squared minus 5 squared. So this x is equal to the square root of 169 minus 25. 169 minus 25 is equal to 144. So we can write this x is equal to square root of 144. The square root of 144 is 12. So x is equal to 12. Therefore, the missing side here is equal to 12. We can now find for the missing trigonometric ratios, which are cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. So if my reference angle will be theta, therefore the opposite side is equal to 5, the adjacent side is equal to 12, and my hypotenuse is equal to 13. Cosine is adjacent over hypotenuse, so that is 12 over 13. Tangent is opposite over adjacent, so that is 5 over 12. So cosecant is the opposite of sine, so if sine is 5 over 13, cosecant is 13 over 5. Secant is the opposite of cosine, so if cosine is 12 over 13, so this will become 13 over 12. Cotangent is the opposite of tangent, so if tangent is 5 over 12, therefore cotangent is 12 over 5. Remember, if the fraction can still be simplified, simplify the fraction. The measures of angle can also be written using the degree, minutes, and seconds, such as 65 degrees, 18 minutes, and 45 seconds. The degree is divided into 60 minutes, and a minute is divided into 60 seconds. Remember that every 1 degree is equal to 60 minutes. Every 1 minute is equal to 60 seconds. The equation above can be used to convert an angle measured from degrees, minutes, seconds to decimal degrees. 65 degree, 18 minutes, and 45 seconds can be converted as 65 degree, 18 minutes, 45 seconds is equal to 65 degree plus 18 times 1 degree over 60 plus 45 times 1 degree over 3600 degree. Each minute is 1 over 60 of a degree. Each second is 1 over 3600 of a degree. Therefore, in decimal, that is 65.3125 degrees. Convert 47 degrees 12 minutes 20 seconds to decimal. So let's write as 47 degrees 12 minutes 20 seconds. So this is 47 plus 12 times 1 over 60 plus 20 times 1 over 3600. This will become 47 plus over 60 plus 20 over 300 for 3,600. So we have 47 plus 12 divided by 60 is 0.2. So the 0.2 plus 20 divided by 3,600 is equal to 0.0056. This is a repeating decimal. Therefore, we can write this as 47. Let's add them all. Plus 47 plus 0.2 plus 0.56 is equal to 47.256 degrees. For 2 decimal, that is 47.21 degrees. Convert 24.2514 degree to degree, minute, and second. So we can write this as 24.2514 degrees is equal to 24 degree plus 0.2514. Then I'll be multiplying it by 60 minute over 1 degree, because for every 1 degree there will be 60 minutes. So this will become 24 degrees plus multiplying 0.2514 by 60 minutes will give us a product of 15.084 minutes. So we can now write this as 24 degrees plus 15 minutes plus 0.084 minutes. So I'll be multiplying it by seconds. So for every 1 minute, there will be 60 seconds. So we have 24 degrees plus 15 minutes plus, so 60 times 0.84 or 0.084 will give us a product of 5.04 seconds. So the answer will be 24 degrees plus 15 minutes plus 5.04 seconds. Thank you.